Hello and howdy, folks. I hope you're all doing well. Root Beer here, looking at question number 24, and I want to thank you for joining me. Hopefully it's going to be a great question. In the diagram, ABC is a quarter of a circle with radius 8, as they have shown. A semicircle with diameter AB is drawn as shown. So draw a nice little... Well, they've already got some dark... I'm going to guess this is a shaded area question, but we'll see. Okay, so we've got this semicircle here. Then we've got a second one drawn with diameter BC. So if we know the diameter is 8, then we've got radii of 4, just thinking ahead. And we want to know the area of the shaded region is closest to. And as soon as I see closest to, and they're rounding to a single decimal point, I think, well, maybe I should grab my calculator. Now, circles, I suspect we're going to see a lot of pi. So we might be able to get by with just 3.14 for in terms of approximating, but we might not. We'll see. We'll see. But you know, sometimes we can get around a question like this without having to use a calculator. And if I can, I'll give it a shot. Okay. I always try and do that. I try and give my calculator a rest and push my brain to keep making connections and keep working properly. Okay, so, as with any sort of shaded region question, my first piece of advice would be break it down into shapes that you know. Now, I see these semicircles, and they're sort of being carved out of the main circle, and the shaded area seems to be what's left over. Now, that's not quite the story, because you'll notice the, let's shade it in green. We're using all the colors today. The green area would sort of be cut out twice. So, we can start to get a bit of a plan of attack, so... full semicircle minus, or sorry, the full quarter circle, silly me, minus one semicircle minus the area of the other semicircle is going to be equal to that outside shaded region. So we can sort of mentally draw these. So what's left when we take away both semicircles? This area up here. But what have we done? We've taken out this, the area that I labeled in green, twice. We take it out once here and another time here. We don't want it taken out at all because that's we still need part of the shaded region. So what do we need? We need to add in that shaded region twice. So plus 2 copies of this sort of overlap region should be equal to my shaded region. Okay, so I think that should work out quite nicely. We just need to, okay, so some of these, like the quarter circle, just 1/4 the area of a circle. What's the area of a circle? Pi r squared. What's the radius? 8, so 8 squared. How about for a semicircle? Well, we know their diameters are 8, so the radii are 4. And they're semicircles, so it's 1/2 pi 4 squared. And then we've got another semicircle, 1/2 pi 4 squared. And then we need to do plus 2 times... I don't even know what you would exactly call that shape. But how do we figure out 2 times this extra shape? Well, that's, I think, going to be the challenge. Let's clean up. So we want this little shape. I think it might be similar to something that's called a lune, L-U-N-E, but I don't think this is quite it. I think a lune is what you get when you take one circle and cut out part of another circle, which is sort of what's going on, but not entirely relevant. It's up to us to figure out, okay, how do I get the shaded area, this overlap area? All right. If I can figure that out, then we should be able to plug that into the formula. Let's draw a bigger picture, shall we? Not too big, but this is good, and yeah, it doesn't look exactly like a quarter circle, but it doesn't need to. It just needs to be good enough for us to draw on it and do some math. So the first thing I note is that this is sort of symmetric, so if I divided it down the sort of middle of the quarter circle, going off at an angle of well, it's a quarter circle, so the full angle is 45 degrees, so we've got, full angle is 90 degrees, so we got 45 degrees here. So that's kind of nice. And then, well, what else are we going to have here? I suppose we could maybe make sort of a triangle here and cut that out of the semicircle. But, where is this intersection point between these two? I suspect it should be right at their apexes, just based on this picture right here. But do we have any proof of that? Well, the peak of the semicircle, it's got a radius of 4, so it's a height of 4 and 4 out there. And then the peak of this semicircle should be 4 up to get to the center of the semicircle, and then 4 over. So yeah, this is a very poorly drawn picture. We can maybe draw a better one. 4 out and up is the same as 4 up and out. And this should be the intersection point of these two semicircles. And so then, what do I have? I've got this nice little quarter circle here. And I could cut out this right angle triangle that's 4 by 4. If I cut out this right angle triangle, what's going to be left? Half of the shaded area that I want. And it's symmetric, so it is going to be exactly half. So 2 times the area that we want is 4 times this sort of half amount. And that's going to be, so 4 times, it's going to be a quarter circle, 4 by 4 quarter circle, minus the 4 by 4 right angle isosceles triangle. So great, now we can get to work. So 2 times the overlap area is 4 times the quarter circle, so 1 quarter, and it's pi 4 squared, minus, and then we've got, it's a base of 4, height of 4, so 1/2 base times height. Alright, so this 4 would cancel out with this 4, and this 4 would cancel out with this 2 to leave a 2 up on top. So we're looking at 16 pi minus 32. So that's 2 times the overlap. And then what have we got? We've got 1/4 pi 64 minus 1/2 pi 16 minus 1/2 pi times 16. Let's just make sure we don't have the formula wrong. Plus 2 times this overlap, so that's plus 16 pi minus 32. 64 and 4 leaves me with a 16. 16 and 2 leaves me with an 8. Again, an 8. So I get 16 pi minus 8 pi minus 8 pi plus 16 pi minus 32. 2 8 pi's and a 16 cancel out. 16 pi minus 32. Okay. So that's the area that's left over. So I guess what we've shown actually is that this area up here is exactly the same as this overlap area because they were both 16 pi minus 32, so that's kind of cool. Now, without using my calculator, 16 pi minus 32, take out a factor of 16. Pi minus 2, so let's say 16 times 3.14 minus 2. So that's 16 times 1.14. And I suppose I can just do old school multiplication. 8 and a 6. And then 0, 4, 1, 1. Add them up. 2, 1, 8, 1. So it should be 18.24, I think. So maybe 18.3. Is that one of the... Yeah, there it is. 18.3. And we're all nice and neat. So 18.3. Probably a little bit more rounding. Let's just double check with our calculator since I do have it handy. But 16 times plus the pi button minus 32. 18.26. So I wasn't that far off. And it's not like these decimal amounts were particularly close to one another. So we're going to say the answer is D. And we're going to get ready for our last question, question number 25, and we will take a look at that in the next video. Thanks for watching.